Dang it. Wait, here's the simulation. You can set that. That's the same thing, it's just written. So we already have the same thing.
Oh, okay, so we just like
Any FTC on that.
Yeah. You do this
Awesome. So you would do H of 17.
So if it's 7 equals 0,
we're trying to find the H of 7.
yeah, but we're given the H.
Yeah, we're
So
H of 10 plus.
Then you go from 70 to
70 to 10. It's just the 10 percent.
can't find somebody just. Yeah, so 70 and 10.
Yeah.
So we started with
But the fact that it's on that makes it a little tricky.
crazy, man.
Crazy.
So the
I don't remember if I've emphasized this before or not, but it's a good time to emphasize. Look at me, everybody, look here. Look. Okay, with the fundamental theorem, you're going to be required on the AP test to use the theorem, I'll say 4 different ways. I have seen questions where they write the question and they're asking you to find displacement, change in position. Well, the fundamental theorem gives 2 ways of finding displacement. For example, in this case where the rocket's just going straight up, there you go. You can focus. Okay. Referring to myself. So the fundamental theorem, look. Remember, the fundamental theorem is not an equation that says this becomes this. It's saying these are the same. So the fundamental theorem says you can calculate displacement if you know the heights. Like if I know the 2 different heights, I can see how different those heights are. That's what displacement is. Questions to that? So one way you use the fundamental theorem is you would use the heights themselves to find the displacement. More often you'll be asked to find the displacement by integrating velocity. So the equation is simply saying 2 ways to find displacement. Pretty good? Awesome. Third way you have to use the fundamental theorem is what you see here. You have to rearrange the theorem to find one of the heights. So by rearranging, I can calculate how high the rocket is at time 70. Any questions on this? Fourth way you use the equation, which is not displayed here, but I'll write it down, is you rearrange differently to get h of 10 alone. So remember, this is just one big number. It's just a number, just one thing. So what I'm going to do is I'm going to subtract this to that side. That will give me an equation that looks like this. H of 70 subtract h of 10, no, sorry, h of 70 subtract the integral. That's going to equal h of 10. So that's the third way you're going to use the fundamental theorem, is to find the position at time 10 using this version of the equation. You want to talk here. So the 4 different ways are find displacement using this, find displacement using this, rearrange to find the height at time 70, rearrange to find the height at time 10. Item C and B is simply saying displacement again. They're just saying, how could you find the change in the height? And I can find that change in the height either way. That's all. Questions? Keep working.
B6, I have life there. Oh, yeah, that makes sense. And Charlie was like,
Okay, a couple things I have noticed. Look, a couple places where people make mistakes. It's very common. No big deal. Sometimes people will look at the table and they'll say, oh, the table starts at 0 and goes to 80. So they make the false assumption that that's what we're always computing. Not necessarily. You have to just read what they're asking for. For example, here it says 10 to 70. So I'm going to start at 10, go to 70. Questions? They said 3 equal subintervals. So I divided those 10 to 70 is 60 seconds. So I've divided the 60 seconds into subintervals that are each 20 seconds long. You want to talk more about that? Then the process is the same it was on everything else. So make sure, hey, remember, when you're computing an integral, if you don't write the integral, you may lose points. So write the integral. I go to the first subinterval. I find the time that is precisely in the middle of the first subinterval. That time is time 20. So I need to be finding the velocity at that time. That velocity is 22. That's why this is 22. Then I multiply by the dt, the time period of the subinterval, which is also 20 seconds. Just put on my chair, Maria. Question? You been bothered by any of it? Apparently, maybe. Okay. This is just using what you found here, so that's pretty straightforward. This computation, 22 times 20. 22 is this value. I am multiplying the 22 by this time period, so I'm finding this pink area. I heard someone ask, how can you tell whether midpoint is an over or underestimate? Because you can't really, they won't ask. So they won't ask about the midpoint. Unless they gave some sort of graph where it became obvious, I suppose. So if I had to, I'd still just draw a picture and try and see if I can tell from my picture. So, other questions? Please tell us.
So if they ask you
No one talks so I can hear. No one talk.
If they ask you for the midpoint, is there always going to be a time with a certain velocity there for you, or will you ever have to?
Yeah. Hey. No, Talon asked an important question. Look, 2 points for Talon. They won't do a midpoint Riemann sum and then give you a subinterval that looks like this, because you have no way of really computing accurately. Like, you can tell the middle time is 75, but they're not going to ask you to go to the graph and try and guesstimate what that value is. Not without more data. So they won't make it ambiguous. Like, I mean, it's possible you could say, oh, the middle time is 75. I look over here and they've got it marked. You know exactly. I'm like, oh, that's why they marked it. So, does that answer your question? Good. 2 points. Yeah. Awesome. Stop that. Okay, look at me. Okay, we've covered all the concepts you need to do the buff packet. The packet is written in such a way to it's meant to kind of guide you item by item. So keep working on the packet. I'm just going to keep walking. Just stop me about anything. The answers are in the back, so you can check as you go. Please don't ever work backwards. Eyes on me for a second. Okay, here's how your brain works. When you learn a concept, your brain establishes a pathway. Okay. If you learn a correct concept, and you use it over and over, the pathway gets stronger. If you are working backwards, here's what I have seen happen. Students will start making up math to make the answer somehow work. Like they're not using real rules, they're convincing themselves that it's logical, but it's not. So they establish false pathways in the brain. Then when they take the test, their brain doesn't know which pathway to use. Like the right pathway or the false one, because it can't tell the difference. So I always tell people, if you really don't know what to do, just skip it. Come and talk to me and figure out what the real pathway is, so all of your pathways are like solid and correct. There's no false pathways in your brain. You do too much on your own where you're just making stuff up, that's all you get is false pathways. So the only point of the answers in the back is like final confirmation. You do everything according to the rules, according to what we've been learning, and then you check and you get the right answer. Pretty solid reason, pretty good chance you've done it right. If you look at the answer and try to force your work to match, you're going to mess it up. So good work. Keep going. Talk to me if you want to. Yeah, come on.